Alright, hello. So in this module, we're gonna be looking at polar coordinates. Alright, and polar coordinates, or our polar coordinate system, is a change from what we're usually used to is the rectangular coordinate system, where we have a x and a y. Alright, so this kind of just changes the formulation as to how we represent points. Right, and the reason we want to do this, we want another way to represent points, is because in the polar system, it might be easier to represent some curves, right? Or it might be easier to generate some more interesting curves. So what you see in front of you is just an example of such a curve, right? So here, this is in polar coordinates. We have r is equal to 10 cosine of 0.25 theta. Right, and I just want to bring this up as an example so you could see and look at how interesting, how much interesting things happen in this curve, right, and how simple the equation is. Right, if we wanted to represent this in the x and y system, it would be a bit more challenging to do. Right? But before we get to that, let's first just kind of start with an introduction into a polar coordinate system. Right, now, our previous formulation has been our rectangular coordinate system, which looks like this, right? Based on the horizontal axis, the x-axis, and the vertical axis, the y-axis. Right? Now, previously we would have points that would be represented by an x-coordinate and a y-coordinate. Right? The x would tell you if we start at the origin, 0, 0. If it's positive, we move in the right direction. If it's negative, we move to the left. For the y-coordinate, if it's positive, we move up, and if it's negative, we move down. Right? Kind of simple formulation here. Now, when we switch to polar coordinates, right, the way to represent a point would be still two quantities, but those quantities are now what I'm going to call r and what I'm going to call theta. Right? So let's look at here. Now, our polar coordinates are going to lend themselves to represent circular type curves much more easier, right? And we can see, and you'll start to see why. Here you see a polar coordinate system, and it even looks circular here. Right, now, in the polar coordinate system, we have the pole, right? Also known as the origin in our Cartesian coordinate system. And we have the polar axes, which is in our rectangular coordinate system, the positive side of the x-axis. All right, now these two quantities, r and theta, right, represent the first part. The r represents the distance from the pole, right? So if the distance is 1 with angle 0, then it would be here. And an angle theta, which is made with the polar axes, right? Similar to our standard position angles. Right? So if I show this point here, P1 pi over 4, right? What that is telling me is that a distance of 1 from the pole and an angle made with the polar axis of pi over 4. Okay? So notice how that is different than our previous formulation of x and a y. Right, so for instance, here I have a more dynamic point here. Right, so a radius of 1.4, right? Again, radius, distance from the pole. Okay, and as I change my angle, increase it, notice that it moves in a circular pattern, right? Because it is always 1.4 radius, a radius of 1.4 units from the pole. Right, so as I work my way from 0 to 2 pi, right, it goes in a circular pattern, right, because that distance between here, the pole, and that point is always 1.4. Right, so if we vary the radius, right, now I'm going to fix my angle. If I vary the radius, right, then it doesn't move in that circular pattern, it just moves along that line there. Right, but always, in this case, 4 units from the pole. Now, one thing that we're allowed to do here as well is, or we have this notion of a negative radius. Right, so here, all right. Now notice here that this negative radius, right, think of this as a line kind of that extends. If you here, that extends out in both directions, right? The angle is still 0, but if it's a negative radius, it kind of reflects it across the origin, all right? And we can do that if we change here. Right now, in this case, the angle is pi/4, and the radius is negative 4.2. So if it were a positive radius, we would find it here, but since again it's negative, still on this kind of line that extends out in both directions, but reflected across the origin, or the pole in this case. Okay, so just keep that in mind here, that we are introducing this idea of a negative radius, right? So when we have that, that just means it completely reflects it across the origin, or the pole in this case. Okay, so what we're going to learn in this module, we're going to learn how to plot points, which we kind of started here already. Right? How to convert between convert between our polar coordinate system and our rectangular coordinate system, and then convert points and equations between those two systems.